Hello 8th graders. We are starting in Chapter 1. Chapter 1 talks about the foundations of geometry. So we're going to start with section 1.1, understanding points, lines, and planes. Now before we begin, this is your first video. Make sure you're writing your notes down in a math journal or a math section of your binder or a separate spiral notebook. But as we go through these notes, I want you to stay organized. In this section alone, we have more than 10 vocab words. So I want you to designate a section in your binder or maybe in your notebook that you have all of your vocab words and your postulates all together. In addition, if you want to do note cards, that could possibly help as well. But geometry is very, very rich in vocabulary. So make sure you're taking the time to understand your vocab words, underline them, make flashcards, whatever you need to do to stay organized and keep on top of them, that would be the best thing. We're going to start with our first vocab word, undefined terms. Undefined terms are the most basic figures in geometry. They cannot be defined by using other figures. So here's what that means. For example, if you would say triangle, you all know a triangle is a three-sided polygon. Well, a triangle can actually be defined by using 3 points and 3 segments. So you can actually say a triangle is connecting 3 segments, etc., etc. So when we're talking about undefined terms, these are the most basic figures. I can't say a point using other geometry terms. A point is just a point. It's one of those basic terms. So here are your 3 vocab words that are undefined terms. The 3 undefined terms are a point, a line, and a plane. Now a point represents an exact location. It has no size and is represented by just a dot. A line is a straight path that has no thickness and extends forever. A plane is a flat surface that extends forever. So we have to first talk about how do you name these things. So a point is named by a capital letter. A line is represented or named by a lowercase letter or 2 points on a line. And a plane is a script capital letter or 3 points not on the line. So we're just going to draw a diagram. So I want you to draw a point, and we're just going to name it P. So this would just be named by naming a capital letter. We could say point P. If we have a line, so let's say we have X and Y. Let me redo that here. We have 2 points on this line, X and Y. And we also have a cursive or a lowercase l. We can name this line by saying line L, or we can call this line XY with a line symbol at the top. Don't forget the arrows. Or, let me make that a little better here. Line XY, or we can say line YX. Now, notice that I can use XY and YX in either order, because when you name a line, you use 2 points that are on that line. And lastly, if you have a plane, so let's say we have a plane, and then we have a script R. Notice we have a script R, and we also have 3 points that do not make a line. So that's important to understand that we can name a plane by using any 3 points as long as they don't make a line. So we can call this plane R, or we could say plane ABC. Our next vocab word is collinear points. Collinear points are points that lie on the same line. Now looking at our diagram over here, we have a line with 3 points that lie on that line. K, L, and M are all collinear. K, L, and N would be called non-collinear. So collinear points, points that lie on the same line. Non-collinear points are points that do not lie on the same line. Our next vocab word, coplanar points. Coplanar are points that lie on the same plane. So if you remember what a plane was, a plane can be labeled by 3 points that are not on the same line. So coplanar points are points that lie on the same plane. So we could pick any 3 points, K, L, and N. Those 3 points do not lie on the same line, therefore they're coplanar. We could say K, M, and N. We could say L, M, and N. Why can we not say K, L, and M? Because they're all on the same line. Coplanar means that they're on the same plane, which means if you're on a plane, you cannot be on the same line. So you can pick any 3 points that are not on a line, and that makes a plane. And that's what you would call coplanar points. The next vocab word is segment. A segment, or sometimes called a line segment, is the part of a line consisting of 2 points and all of the points between them. Now those 2 points are going to be called endpoints. So we're going to draw a diagram and name it. So we're going to draw 2 endpoints, which are called A and B, and we're going to connect it with a segment. So the 2 endpoints are points A and point B. We can name this using 2 points, and they have to be the endpoints. So we would call this segment AB or segment BA. The next vocab word, an endpoint. An endpoint is a point at one end of the segment or the starting point of a ray. So in this case, if we look at our segment AB, we know that this is an endpoint right here. A is an endpoint and B is an endpoint. So we can name them by either point A or point B. Those are endpoints. We use a capital letter. Our next vocab word is array. Array is another part of a line. It starts at an endpoint and extends forever in one direction. So we're going to draw 2 different rays. Now looking at these 2 rays, we have one side of the ray that has an endpoint and the other side goes on forever. Obviously you can see in both examples that R is our endpoint. Point R is our endpoint. There is only one way to name this ray. The only way is by starting at the endpoint. You have to start at the endpoint. So in this case, we start at point R. And then you can name any other point on the line. So we could say this is ray RS. You cannot do this. That does not work. The arrow always points to the right. So this example here, we start at R, we go through S. Therefore, it is called ray RS that looks just like this. Next vocab word, opposite rays. Opposite rays are 2 rays that have a common endpoint and form a line. So if I would tell you that we want to name or draw ray EF and ray EG, and if we said they are opposite rays, they would look like this. Ray EF, we know that E has to be the endpoint, and F has to be anywhere on that ray. Ray EG has to also start at the endpoint, but it goes the opposite direction. So G has to be at any point here. So what did you just make? You should note that you just made a line. Opposite rays form a line. Example 1. Let's draw and label each of the following. So we have 2 things we have to do. First one, a segment with endpoints U and V. So we're going to draw a segment with endpoints U and V. So endpoint, endpoint. We can label them either way, U or V. That's it. The next one is opposite rays with a common endpoint Q. So opposite rays, you know, do what? They form a line. So we could say this right here is your endpoint. That's your endpoint Q. But remember, you have to draw a ray. So we could say ray Q, and you can make up any other point you want. So you could say that's ray QR, and this is ray QT. So we can say QR goes this way and opposite ray QT, and obviously it makes a line. The next vocab word is called a postulate. A postulate, or axiom, is a statement that is accepted as true without proof. Now, these are all postulates that are basically a statement that you're going to use to prove things. You can use these to prove other things. You don't have to prove these statements because they're true. Now, as we go through and talk about postulates, my suggestion would be to write them down separate than vocab words, because you're going to have numerous postulates and theorems that you're going to have to know. So we're going to start by talking about postulates, about points, lines, and planes. Now this is on page 7 in your book, and I'm taking this right out of the book. So we're going to talk about the first 3 postulates. As we go through postulates, you'll notice the book numbers them by the section number that we are in and the number of postulates that we have gone through. So right now we are in section 1.1, and we're going over postulate 1, postulate 2, and so on. Here is something I want you to understand. You don't have to memorize these numbers. These are different no matter whatever math series or book you use. You don't need to know these. This is what you need to know. So I am never going to ask you, what is postulate 111? Or I'm never going to say, which postulate tells me that through any 2 points there is exactly 1 line. You don't need the numbers at all. All I care about are the actual postulates, the sentences, the statements that we know already are true. So postulate 111 says that through any 2 points, there is a line. That means if I have a point, I have another point, there is a line that goes through those 2 points. The next postulate says through any 3 non-collinear points. Now remember, 3 non-collinear means 3 points that do not lie on a line. So through any 3 non-collinear points, there is exactly 1 plane that contains them. So we know that there is a plane, and I'm just going to label it purple here. We can say this plane, remember a plane is like a flat surface that extends in any direction infinitely. So any 3 non-collinear points make exactly 1 plane that contains them. The last one says, if 2 points lie in a plane, then the line containing those points also lies in the plane. So for example, let's say we have this point and this point, and they lie in this plane, then the line that goes through those points also lies in that plane. Example number 2, and this is on page 7. Name a line that passes through the 2 points. Name a plane that contains 3 non-collinear points. So let's start with the first one. Name a line that passes through the 2 points. Well, what line passes through the 2 points? You could say line GH. If you left it at that, you'd be done. But what are some other names for line GH? We could say line HG. We could also say line N. Now you don't need all 3 of those, you just need any one of those would be an answer for the first example. Now the second one says name a plane that contains 3 non-collinear points. Non-collinear points are points that do not lie in the same line. So give me a plane that contains those 3 points. We would say plane G, H, F. I am now on the top of page 8. Now you don't need to write any of this down that I'm going to write down until I tell you to do so again. But if you remember from last year in algebra, recall that a system of equations is a set of 2 or more equations containing 2 or more of the same variable. So you remember, for example, if you had x plus y equals 4 and x minus y equals, let's say, 2. Now, if you graph them, you would graph them both on a coordinate grid, and you would figure out the point of intersection. So if you graph them, I'm just going to roughly graph these. So if you graphed the top one, and once again, this is not accurate, I'm just quickly graphing them to make a point. And if you graph the second one, let's say you had that. You know that the solution to this system of equations is this point where the two lines or the two equations intersect. These coordinates also locate the point on all the graphs of the equations in the system. This is where they intersect. That's your answer. This intersection is going to lead us into our next postulates. Now, what we had here are two lines that intersect. You now can also have planes that intersect. Here are your last two postulates in this section. Postulate 114. If two lines intersect, then they're going to intersect at exactly one point. Now, I'm hoping that makes sense to you, that if you have two lines that intersect, they intersect at one point. The same is true for 115, but this time you have planes. If two flat surfaces intersect, so if you had two planes that intersect, now I'm going to try to draw this. I'm going to do the best I can. So you can look at the diagram that I just made here, that we have a blue plane and we have a purple plane. They intersect. It'd be like if you took two pieces of paper and you cut like a slice in one of them and slid it on top of to another one. Those planes, now remember, the planes go on forever. So they're going to constantly go on forever. They don't just stop where they're looking at in this picture. They're going to meet on a line. So this line right here, that line is the intersection of the two planes. And that's what postulate 115 says, that if we have two planes that intersect, then they're going to intersect at exactly one line. At the end of each section, I'm going to give you the vocabulary and the postulates in a list that you should know from this section. So make sure you have these written down somewhere and that you study these and understand what the vocabulary and the postulates are.